Welcome back. I will show you now how to use subroutines. We saw in class the other day that a subroutine is just another subprogram that gets called using the BSUB instruction. Upon completion of the subroutine code, the instruction RET is a branch that takes you back to the instruction following the BSUB instruction. We also saw that the address of the return instruction is stored in a special register called return register RR. Here is a reminder, the link to the didn't mean to do that. The link to the course website where you will see samples is shown on the at the top of this file here, and that's where you can see samples. Now let's take a look. If we follow this link, I shouldn't do that. Okay, we followed it. Okay, see what we got. We'll see a bunch of stuff in here, but we want to look at these two here. So if we click on this, we can see the program. Let's look at it for a moment. Um, the documentation says the name of the program is linear equation. And you remember from algebra that a linear equation looks like this. You have a coefficient for the variable x and you have the constant. So that a linear equation, if I have a and b, I can evaluate it for various values of y. The pseudocode is simply I need variables for y, for a, b, and x. I need to read the coefficients a and b, and then I need to read the value for x, the variable x. We will echo what we read, then we will make the function call. We're calling the function f. The result will be returned and stored into variable y, and we will display the value of y. Couple things about the subroutine. When we write it, we have to take care of parameter passing. And in this case, the function subroutine needs only one parameter, which is passed in the accumulator. And the protocol is if you produce a result, it is an int function. If I produce a result, how do I get the result back? In this case, we return the result in the accumulator. The function itself has to make use of the coefficients, and the coefficients are essentially global variables, which are not passed. Okay, so the data section of our program establishes these variables. And again, because this comes first, all the variables are really global. The program begins here by us reading the inputs, echoing the inputs, and then preparing for the function call. We said as part of the protocol for passing, for calling the function, that we're going to put the value of x in the accumulator before we make the call. So we put x in the accumulator, we make the call. Now notice the code for the function is down here, okay? And after the recall, after the call is completed, the protocol says that the result will be in the accumulator. So after the call, we take what's in the accumulator, store it in y, and rewrite y. And the program ends here, okay? The program execution ends here, but the source code does not. It ends down here. So this is pretty much like putting your main first, followed by the functions. So this function does what? When I enter the accumulator contains x, we multiply it times the coefficient, so the accumulator will contain a times x. Now we add b, which means the accumulator will contain a times x plus b, which is the value that we want to return. How do we return it? Well, first of all, we leave the result in the accumulator. So we've got that. And now we execute the return statement. Okay? So that's what it looks like. Let's show you that it really works. So let's take the code much stuff here. Don't need to see that anymore. So let's compile it. Linear equation.how. Okay. We're going to assemble it or translate it. Technically, we're not really compiling it. You compile high-level languages like C++, Java. Okay. So here's what we have. Here's our code. Here's the machine code. And now we're ready to actually run it. And so we're going to have the equation 0 is the first coefficient and 5 is the second coefficient. And I give it the value of 7 for x. We really have the equation y equals 5. So the answer ought to be 5. Let's do a different one. Let's run it again. We're going to say the coefficient is 2x plus 4. So if I enter the value of x of 3, I should get the answer 10. 2x, 2 times 3 plus 4 is 10. So this shows you that the subroutine call works. So let's take a look at the trace here. Okay. Here's the execution trace. Notice that the instruction execution is sequential. 0, 0, 0, 1, 0, 2, 0, 6, then 0, 7. And what happens when we make the call? All of a sudden we jump down to instruction at address 11, which is the body of the subroutine. So we multiply and we add, and the return statement takes us back. Where does it go back to? It goes back to 8, which is the instruction that comes after the call. So the return the return is going to take you to this instruction following the call. All right, so with that we will stop. Okay.